If I look at something like this guy, we're kind of doing the same thing, but now we're doing it in reverse to go back to the angle measurement, okay? And so when you look at something like this guy, the entire way around the circle in terms of the angle is 360 degrees, okay? So the circumference in terms of angles is 360 degrees. That's how I get the whole way around the circle. But I don't want the entire way around the circle. I don't want the entire 360 degrees. I only want a fraction of that. And the fraction that I want is this guy over the whole thing, over the entire circumference. And so once again, we still have to find the actual circumference here. It's 2 pi r, which is the 3. So that's 6 pi. And once again, 6 pi is 18.84 inches for this one. And so that kind of completes my fraction here, 18.84. Okay? And so when you think about the fraction of this arc, well, it's that partial circumference measurement over the entire circumference. That's the fraction that it represents. And so here I do the same thing with angles, but it's kind of reversed. Instead of the angles giving me the fraction, now the circumference and the arc length are giving me the fraction. Okay? And so once again, this is a job for my calculator. And when I plug it in, I get approximately a 45.01. I'm just going to round it to 45 degrees. Okay? So the x value this time is 45 degrees. And once again, we can set this up as a proportion. Instead, I could say, hey, you know what? The partial measurement for the arc in terms of inches is this guy over the entire measurement for the circle in inches, which is this. Okay? So it's basically inches over inches, the part over the whole equals, well, the partial degree, I don't know what it is. That's what I'm trying to find. That's x, okay? I want to know how many degrees it is. Over the entire way around the circle is 360. And then once again, I cross multiply and solve, okay?